Okay, let's test this out. So let's go to our manufacturing format. Let's create a new setup using a solid. It's a milling operation. We're going to choose our Z plane and X axis. Our Z plane is the top of the stock. Our X axis is the side of the stock. And we're going to go from a selected point, meaning that corner, and we're going to choose for our model the actual real body. Everybody got that? Thank you. Okay, gentlemen, thanks for following along. Let's program the first side of this real body. So I've already created a setup. I'll go through that with you guys. I've created a new setup. The stock is body number 2. Body number 2. So I've gone ahead and selected body number 2. The Z-axis plane is the top of the stock. We're going to flip that Z-axis plane around right now and choose our X-axis plane. The body that we're choosing is the body of our real body. Nope, wrong one. So everybody's stock and first setup should look like what I have on the screen. And let's just exit out of this. So as you can see, we have some stock at the bottom of our part. That's what we're going to use to hold on to the vise so we can machine all the way down in this first setup. So here we go. We're going to face the part. I'm going to create a new tool. Tool number 1. Cutter. It's a face mill. 2.5 inches. 2.5 inches, 0 corner radius. The rest of this stuff is fine. 6,000 RPM because that's the max that we have at the school, and 50 inches a minute. Post processor, tool number 1, hit OK. OK. We don't need to choose anything for our stock. I would like you to choose climb cutting and extend before retract. Hit OK, and this should make our first tool path. So if you want to see that in simulation, it's real simple. There it is. Okay, so now let's rough the body of this part out. Very simple process. We're going to choose a 3D adaptive clearing. We're going to call our 1/2 inch end mill tool number 3. It's important, guys, when we get to get the tool numbers correct so we don't have to set up the tools on everybody's job when we finally get back to the class and we actually start making parts. But it's a flat end mill. It's a 1/2 inch in diameter, so that's 0.5. Our feed and speed, let's max it out at 6,000. And let's go with 75 inches a minute. We'll be pretty conservative here. We'll ramp at 75 inches a minute. Post processor, tool number 3. Hit OK. So let's go through our tabs here. We're not going to choose anything in our geometry tab. We're going to go from the model bottom or from the selection. I like to use selection personally. And I'm going to go negative 0.30 thou. Okay, our optimal load, let's make that 150 thousandths of an inch. And let's step down every 1/2 of an inch. That makes our fine step down 1/2 inch. Since it is a roughing pass, we have a stock to leave of 0.2 on both radially and axially. So let's hit OK and let that generate. Okay, while that generates, let's move on to our finishing pass. It is a contour. We'd like to finish this whole thing along the outside. Let's use our same 1/2 inch end mill. Since it's a 2D path, it's not model aware, so we have to choose our lines. I've chosen the top outside line, and I'm going to choose the bottom, and I'm going to go -0.01. It's important that we left 30 thou in the roughing pass because we had 20 thou to leave. So essentially our roughing pass is only 10 thousandths above or below the bottom of the part, which is why our finishing pass is going to be 0.5 below the part. Now our flute length is not long enough to get this whole distance, so we have to break this up into multiple depths. Let's click box for that. Let's break it up into 0.75, 3/4 inch, and this one's important. Find the use even step downs so that it looks the same, and go ahead and hit OK. So we've got an error here. Let's see what happened. Show log. Toolpath exceeds clearance height. Let's figure that out. Let's raise our clearance height to 0.8. There we go. So whenever you have that error, hit show log and it will tell you sort of what's wrong with it. I am going to change one thing here. I do want to put our entry position on the corner so that it's less visible when we make the part. Okay, let's take a look at this adaptive clearing that generated while I was making that path. 3D adaptive, remember, is model aware, so it will use the model as its point of reference. So, but what I can see from that toolpath is the 1/2 inch end mill was a little bit too big to get inside of this pocket. No problem. Let's choose another 3D adaptive clearing. I'm going to choose tool number 2. Let's make it tool number 2. And it is a bull nose end mill, 3/8 in diameter, and our radius is 0.0625. Our feed and speed is 6,000 RPM, max it out. And let's use 100 inches a minute. And let's ramp at 100 inches a minute, not 1,000. Tool number 2, hit OK. Okay, so it's important that we restrict the amount of room that it does the adaptive clearing to simply the inside of the part, because we've already got the outside of the part with the bigger end mill. So I've chosen the chain, machine boundary, selection. The chain is the inside of the part, and we can leave our tool on the inside of the boundary. And hit OK. So what this is doing is creating a roughing pass along the inside of this part up that small conical ramp. So now let's make a contour. Let's go back to our 1/2" end mill. Let's choose that edge. That edge, by the way, is below the surface of the part, so it's not finished with the 1/2" end mill. Or I'm sorry, the facing mill. So I've chosen that edge. What I need to do here is leave a negative radial stock to leave. Negative 50 thou, but not a negative axial thou. We want 0 in the axial thou. And something is not happy. Ah, it's an easy one. My arrow was on the wrong side. Okay. So while we're here and we have this 1/2" end mill in this pocket, let's go ahead and finish this wall. So we're going to do a 2D contour. Our tool is the same. We're going to choose that contour. We don't need to choose anything because we chose our selected contour, so we don't need to choose anything for our height, and then just hit OK. Okay. That is a slight problem, and I hope that you can see what it is, but that tool is bigger than this distance here. So that's not going to work for us. So let's choose a different tool. Let's choose a 1/4" end mill. So we'll make our 1/4" end mill tool number 4. It is a flat end mill, 1/4" in diameter, 6,000 RPM. And our feed rate, let's make it 75. And that's fine. So what you can see here now is we have a 1/4" tool path that goes along the outside of that part. What I'd like to do now is make an identical 1/4" tool path along that edge so that we finish this entire bottom floor with the same 1/4" end mill. All right, so now what we have left to do is this conical taper. We can do that with a ball mill, or we can do that with our bull nose. Since our bull nose is already in the part and set up, let's go ahead and do it with the bull nose. So it's a 3D, and let's try a ramping tool path. Let's choose our tool. Tool number 2, it's our 3/8 0625 bull nose end mill. Okay, I'm going to limit the machining boundary to the selection of that. This one's important, guys. Tool on outside of boundary. Make sure it's not on inside or center line, or it won't get to where we want it to go. Okay. Let's limit our bottom of the part to, whoops, let's turn our sketches off. Limit the bottom of a part to 1/1000th of an inch above that bottom floor, because we don't want to drag that tool along that bottom floor as we ramp down this part. Okay, and then let's limit our top to 1/1000th below that surface that we already did a nice contour on. We want a nice pretty finish, so let's limit our step down to 10,000ths of an inch. And let's see what we get. Okay, that looks great with the exception of the tool is trying to go into that hole that's not there. So let's change that. When we choose our machining boundary, let's select that line as well. That will limit the amount of tool interaction to between those two spots. And there you go. So we have one more part to do on this path, and then we have to chamfer and clean up all the edges. So we've got to drill this hole. Let's just see what diameter that hole is. 375. Okay, so I'm going to give you guys a little trick. Since you only have 10 tools in the machine, and setting tools takes time, we're going to use our 1/4 inch end mill to bore that hole. So it's a 2D, it's not a drilling operation, it's a bore. We're going to go select our 1/4 inch end mill, which is tool number 4. Leave all of the parameters the same, except the circular faces. We're going to select that bore. Okay. I would like to start the bore 50,000ths above the hole, and I would like to limit the bore to only go negative 50 thou below the bottom of the hole. That way we make sure that it starts above the hole and we make sure it clears the entire hole. So our pitch, which is how aggressive we're going to screw down that part into that hole, let's make that 20 thousandths per revolution. And hit OK. So now what we have here is a faced, roughed, outside finished, inside roughed, finished that top floor, finished this lower floor in 2 operations. We've ramped and created a nice 3D tool contour coming straight down that part, and now we've bored out that hole. So all that's left to do is chamfer it so we don't have any hand deburring work to do. So let's choose our 2-dimensional chamfer. And post-processor, it's tool number 5. It is a chamfer mill, 45 degrees. Diameter is 3/8 of an inch. Our tip diameter, some of you guys were getting this one, missing this step last time we were in class. Our tip diameter is 0, so it goes to a point. 6,000 RPM and 75 inches a minute. Hit OK. OK. So now let's choose to chamfer these edges. Okay. Let's put a nice healthy 20 thousandths chamfer on that. Let's offset the chamfer tool 80 thou, and let's leave the chamfer clearance of 5 thousandths of an inch. Okay, so we've chamfered this part. So I'm going to go ahead and simulate the whole thing so you guys can see it, and then we'll post it up. So let's simulate the part. I'm going to show the stock, not going to show the tool paths. That'll just get confusing. So here we go, guys. Okay guys, that's op1 on our real body. So I'd like you guys to program that part. Look for a video from me tomorrow, programming the opposite side. Thank you very much. You guys have a good night.